So adding 3 more rules to what we learned in 5.A.4. These rules are more so, as it says here, about clearing parentheses than really so much the simplifying. It's still part of the process. But the idea is, as we work to get these final answers in these problems, these are really the 2 things we want to work on. We want one of each base, which is where those first 2 rules came into play. We were able to combine bases through multiplication and division. We also don't want parentheses in our final answers either. So there's 3 situations that involve parentheses. The first one, what we call the power rule, notice it's just one base to the power, but then that expression raised to another power. Okay? Sometimes I'll call this the power to a power rule. But I want to be careful because you don't actually raise this number to this number. What it turns out is when you have a base to a power raised to a power, if you multiply those 2 numbers, you will get your new exponent. Now, right here is where some confusion can come in, because now I'm showing you a rule where you multiply exponents. But notice it's not the rule from previous section, from 5.A.4, where you're multiplying bases, right? We said when you multiply similar bases, you add exponents. A power raised to a power is when you multiply them. And again, we'll make sense of it really quickly here, because if you have a cubed squared, right? Think of it as you have 2 copies of a cubed. So there's your 2 copies of a cubed. Now use the rule we just saw on the last page. A cubed times a cubed, same bases. So add the 3 and 3 and get the 6. But rather than having to write this out every time, that 6 could simply come from 3 times 2. So that's us using our rule to bypass all this extra writing out stuff. Now, the other 2 rules are, again, certainly about simplifying things inside parentheses. They're called the power of the product and power of the quotient, and they work the same. If you've got a product, so things multiplied inside parentheses, and then that's raised to a power, you're able to apply that power to each piece. I'm going to be careful to not draw arcs or really use the word distribute, because that can be a little confusing, and we'll see an example later on that we definitely don't want to confuse with this rule. I use the word apply. We can apply that power to each piece of the product. And so again, real quick example, if you had a times b, 2 things, but that's cubed, you have 3 copies of a times b. There's your 3 copies of a times b. But that's all multiplication. Nothing but multiplication in there, so we can reorder it, because multiplication is, again, commutative. So I can say there's 3 a's multiplied together and 3 b's multiplied together, which would be a cubed b cubed, which is nothing more than taking that 3 and applying it to both of those bases. And then same exact thing with the fractional form, the quotient form, fraction to a power. You can apply that exponent to both the numerator and denominator. Another small example here, squaring AB. So you have 2 copies, but that's a times a squared on top, b times b squared on bottom. So the 2 can just apply to both top and bottom, numerator and denominator. Okay? So with those rules, we'll take a look at a couple more examples where we will start to eventually combine all these rules. But first, just identify base to a power. This is the power rule. And our power rule says to multiply that 4 and that 3. That's all you do. That's it. And you're done. X to the 12th. Now here, you've got multiple things inside parentheses raised to a power. So the first thing we will do is we will use the power of the product to say that this here can be broken apart and this 2 applied to each piece. Now to apply it to each piece, I'm going to take the time to write it. X cubed squared. So I need those extra parentheses there. Now, y squared, I don't really need extra parentheses. I could just write y squared. But now, there's a little more to do, because in breaking this thing down, I've created the power rule again, right? Similar to this one. So x to the 3rd to the 2nd. That's a situation, again, where we multiply 3 times 2. Get x to the 6th, bring down the y squared, and there we go. The last one is, again, a reminder that numbers are going to work differently than exponents, right? Coefficients are different than exponents. First thing to point out, there's multiple things. There's 3 things inside here, right? This times this times this, all raised to the 4th. First thing I will do is I will use that power of the product and break them all apart. Take the negative 2 to the 4th, x squared to the 4th, and y cubed to the 4th. Pretty much need all those parentheses there to write that correctly. Now, negative 2 to the 4th, you actually do the exponent work. Don't just take negative 2 times 4. Right? This is not a power rule, not a power to a power. This is negative 2 to the 4th power. So remember what we talked about earlier. First of all, if we do 2 to the 4th, 2 times 2 is 4, times 2 is 8, times 2 is 16. And it's a negative power to a negative number to an even power. Remember, with even powers, you've got pairs of negatives, so you get a positive in the end. Again, if you don't recall that trick, you can write it out, but we can know that this is going to be a positive 16 for that reason. Now, x to the 2 to the 4, there's our power rule to multiply. 2 times 4 is 8. Y to the 3 to the 4, power rule, multiply. 3 times 4 is 12. And there's our final answer. All right, a couple more examples on the next page here. So here we got 2x squared times 3x cubed, but again, even without the dots written in there, that's all multiplication, times, 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 all in there. So this is just multiplication, so we could again take the time to reorder if you want, and you don't even have to, but I'm going to one more time here. I'm going to reorder it so the numbers are next to each other and the x's are next to each other. That says the exact same thing. And now I know that 2 and 3 multiply to give me a 6. Here, 2 and 3, notice where they're at. They're in the exponents multiplying similar bases. This is where we add those exponents, right? 2 plus 3. This is our rule from the previous section, giving us x to the 5th there. So again, that's the thing to watch out for. Don't get used to multiplying from those previous examples. This is still that rule of similar bases multiplied means you add the exponents. All right, number 5 here. Big fraction raised to a power, so the first thing we'll do is we'll split apart the fraction, right? We can split apart this fraction into the numerator to that power and the denominator to that power. That's the quotient rule, just break apart. Then in the numerator, we've got multiple things to the second, so I'll break those apart. 3 squared and x to the 4th squared, breaking that apart with the product, power of the product. Down here, we don't really need to break anything down, but we just have the power rule, y to the 3rd to the 2nd. Here's where we multiply and get y to the 6th. And then here we can do 3 squared, that's 2 copies of 3. 3 times 3 is 9. Here, x to the 4th to the 2nd, that's a multiply. 4 times 2 is 8. Again, the y to the 6th for our final answer. So that had a lot of rules. That had every rule, every one of these last 3 rules in it, right? Had the power of the quotient, power of the product, and the power rule. Basically backwards. That's rule 5, that's rule 4, and that's rule 3 from the previous page. All right there. And then number 6. Another big product, just basically a bigger example of example 4. Stuff multiplied together times stuff multiplied together. I'm not going to reorder it this time. I'm just going to point out that we can take the negative 2 and negative 4, multiply them together and get an 8. The m squared and m to the 4th, multiplying similar bases means add the exponents. 2 plus 4 is 6. And n squared, remember this n is an n to the 1st. So multiplying similar bases, add 1 and 2. Gets me 3 for my final answer.